Bismillahirrahmanirrahim. Value of this week is discipline. And here is the quote: success starts with self-discipline. Assalamu alaikum students. Welcome to class pre-9th. Topic of this video is radicals and radicands. Content of this video is introduction, difference between radical form and exponential form, properties of radicals, transformation of an expression given in radical form to exponential form and vice versa. Introduction. Nth root. If n is a positive integer greater than 1 and a is a real number, then any real number x such that x raised to power n is a is called the nth root of a, and in symbols is written as x is equal to nth root of a, or we can write it as x is equal to a raised to power 1 by n. Radicals and radicands. In expression nth root of a is called radicand, symbol is called radical sign, and n is called index. The symbol of square root. This symbol is radical or radical sign. The expression under the radical sign is the radicand, and the index defines the root to be taken. Remember, square root of a is usually written as without index 2, only a radical sign with a. Difference between radical form and exponential form. Radical form and exponential form. In radical form, the radical sign is used. X is equal to nth root of a is a radical form because here we use the radical sign. In exponential form, exponential is used in place of radicals. X is equal to a raised to power 1 by n. It is an exponential form. For example, cube root of x, fifth root of x square. These are the radical forms because in both examples we used radical sign. Now look at the examples of exponential form. X raised to power 1 by 3. This showing the same thing in exponential form. Cube root of x. The second one is fifth root of x square, and here we represent it as x raised to power 2 by 5. In exponential form, we write the power in quotient. In numerator, we write the value of exponent, and in denominator, we write the value of index. Look at the last example, x raised to power 2 by 5. Here, 2 is the exponent and 5 is the index. So keep this thing in your mind. Properties of radicals. Look at the first property. N power of nth root of a is a. How? As you know that we express the power as a quotient, and in quotient we write exponent in numerator and index in denominator. Here exponent is n and index is also n. So n divided by n is 1. So we have only the value of a. Second property. Nth root of the product AB is product of the nth root of A and nth root of B. It means we can separate the radical symbol in product case. Third property is nth root of a by b is nth root of a divided by nth root of b. It means in the quotient form we can also separate the radical sign. Fourth property, nth root of a raised to power m is m power of nth root of a. It means that the exponent of radicand can be expressed as the exponent of radicals. Fifth property, mth root of nth root of a is mnth root of a. It means that both index value will be multiplied. Transformation of an expression given in radical form to exponential form and vice versa. The first value is fifth root of minus 8. It is a radical form. Its exponential form is minus 8 raised to power 1 by 5. The next value is cube root of x raised to power 5. It is again a radical form and its exponential form is x raised to power quotient, and in quotient we write exponent value in numerator which is 5 and the value of index in denominator which is 3 here. So x raised to power 5 by 3 is an exponential form. The next value is y raised to power 3 by 4. It is the exponential form and its radical form is fourth root of y cube. We write the denominator value as an index and the numerator value as a exponent. The fourth value is x raised to power minus 3 by 2. It is again in exponential form. Its radical form is square root of x raised to power minus 3. Here we write the denominator value as a index and numerator value as the exponent. We have an activity. Look at this symbol. What does the following symbol represent? And look at this expression. What is the radicand of the expression? Also look at this expression. What is the index of the expression? Thank you. Inshallah, we will use these definitions and properties in exercise 2.3.